Let's take a look at graphing a cosine function now. We've already looked in class at graphing the sine function. So now let's take a look at cosine. Similar to when we looked at sine, there's going to be 5 key values, 5 key aspects of the graph that we're going to consider when we graph cosine function. So first let's take a look at angles. As we go from 0 to 2 pi, our angles increase. We have pi over 6, pi over 3, pi over 2. That's in Q1. And we can see that the cosine functions start at 1 and then decrease to 0. So in the first quadrant, we are decreasing. In Q2, we are further decreasing, and we get as low as, or a minimum of, -1 at pi. Then in Q3, we are still in negative territory, but we are increasing to 0. And then in Q4, we now are in positive x territory, and we increase from 0 to our maximum point here at 1. So looking at these key values here, when x is 0, cosine is 1. When x is pi over 2, cosine is 0. When our angle x is pi, we're at -1. 3 pi over 2, our cosine is 0. And last but not least, when we've made the complete cycle and we have an angle of 2 pi, our cos is back up at 1. So looking at our graph here, we can see these points. At 0, we're at 1. At pi over 2, we're at 0. At pi, we are at -1. At 3 pi, we're back at 0. And at 2 pi, we're at 1. So for cosine, we have 2 x-intercepts, and then we have 2 maximums and a minimum. This is a little bit different than sine that had 3 x-intercepts. Here we have 2 x-intercepts. So now, considering what we're going to do here to graph, and it's very comparable to what we did with sine. There's going to be some key information that we're going to look for. A is going to be our amplitude. So the absolute value of A is going to define our max and then our min. This B here, we're going to use that to help us decide what the period is. And then C here is our phase shift. So in the plain vanilla cosine function, we start at 0. A phase shift would represent a starting point for our cycle at something other than 0. And we're going to use this information. So let's take a look at our first example here. Y is equal to -4 cosine of pi x. And we're going to be taking a look at this ultimately for x between 2 and -2. But right now, let's just concentrate on getting one period of this. So we need our amplitude. So let's identify A, B, and C. So in our example, A is -4. B is pi, so remember B is the information right in front of the x, and then we do not have a C here. So C would be 0. There is no phase shift that we're going to be taking into account here. So our amplitude is going to be 4, the absolute value. And then this negative sign tells us that we have a reflection here. Instead of going down initially, yep, we're going to be going up. Now, let's use this B to find our period. Period, similar to sine, is going to be 2 pi over B. So let me do this here, 2 pi over B, and then because our B is pi, I put it in there. So pi's cancel, and our period here is just 2. Now, this is a little bit different than what we saw with sine because our examples all included some angle notation such as degrees or pi. But a period that doesn't have pi in it would be very reasonable to use. If you think about activity going over time, we don't normally talk about 3 pi minutes, but 2 minutes or 3 minutes would be some terminology that we would use. So we know that our period, we're going to have a full cycle in 2, some period of 2, be it 2 hours, 2 minutes, 2 seconds, if it is time. And we know from the work that we did with sine that in order to generate our 5 key values, we're going to take our period and divide it by 4. So in this case, we're going to divide our period of 2 by 4, and we can simplify this fraction to 1/2. So now, on our table here, we're going to fill in these x values, which are our angle values. Because there was no phase shift, we are going to be starting at x equals 0. And now to generate our second key value, we have our 0 and we are going to add 1/2 to it to give us an x of 1/2. To generate the next, we take our 1/2, we add another half, and we're at 1. Now, obviously, I'm doing this, and probably some of you are saying, you could do this much faster. Yeah, but I want to make sure everybody's clear in their notes how we're getting these key values. Then we have 1 plus 1/2, which I'm going to write it as 3/2, but that's also 1/2. And last but not least, 3/2 plus 1/2 is 4 over 2, 4/2, which would be 2. So 1, 2, 3, 4, 5. There are our 5 key angle values that we're going to use to generate our cosine curve. So now we're going to consider the cosine of each of these angles. And if you wanted to, you could substitute in for x, the 0, the 1/2, then the 1, then the 3/2, and then the 2 to generate these. But we know because we have specifically chosen these x values the way we have, these will just represent our 5 key cosine values. When cos is 0, cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And finally, cosine of 2 pi, we're back at 1. These are our cosine values when we have an amplitude of just 1, but we don't. We have an amplitude of 4, and then we have a reflection. So to represent that, we're going to multiply each of our cosine values by the -4. 1 times -4 is -4. 0 times -4 is 0. -1 times -4 is 4. Again, we have a 0. And last but not least, we have a -4. So now we have our 5 key angle values and our 5 key cosine values. So let's take a look at graphing this. Let me get this here. And so now let me switch colors. We have x is 0. So here is our 0 angle, and our cosine is -4. So we are down here. So contrary to normally starting here, we have a reflection. Now, when x is 1/2, we have an intercept here of 0. When x is 1, our cosine value is 4. When x is 3/2, we have another x-intercept of 0. And then at 2 here, we are back down to -4. So here are our 5 values. When we connect these, we can see that we have cosine flipped over. Now, this is one period here. We can see one complete period. and it takes place 0 to 2, which is what our period is. Our period is 2. However, in this example, we were asked to graph this between -2 and 2. So here's 0 to 2, but we need to continue this graph over here. So we continue the pattern. We know from here we would go up to an intercept. At -1, we're going to be at 4. Then at -3/2, we're at 0. And then at -2, we are back down here at -4. So I'm not the best artist, but that would be our graph here between -2 and 2. So we can see some things from this graph. One thing that we can see is that cosine, we know cosine of x is an even function. An even function has, symmetry with the y-axis here, and we can see that very clearly in our graph. If we could fold this over, this side would lay exactly on this side. So we're seeing that even function here. The other thing, I haven't continued this, but this would continue on. So let me do that with little arrows here so you could see that the domain here of our cosine function is going to be -∞ to infinity. And here, our range here is not the usual -1 to 1. Our range here is -4 to 4 because of the fact that we have changed our amplitude. And here, our period is 2, which is different from our normal period of 2 pi. Because of this b, we have changed up what the normal period we would expect to see.